Hello, am I audible? Nida, Abhinav, are you there?
Yes, sir.
Okay, just tell me what we did in last class. Okay, geometrical meaning of cross product. Got it. Now, on the basis of dot product and cross product, we have to define relationship in between them. That is called Langrange relation. A dot B equals to A B cos theta, and A cross B mod equals to AB sine theta. So if you divide these two terms, you will get A tan theta equals to A cross B mod divided by A dot B. This is first relation in between them. Next is, if you square them and add, you will get A dot B square is equal plus A cross B mod square. You will get A square B square only. So these two relations on the basis of dot product and cross product is termed as Lagrangian relation. Now I'm giving you one problem related to this. If A dot B is equals to root 3 times A cross B mod. Using this, try to find theta. Using the first relation, try to find theta between two vectors. we have tan theta equals to A cross B mod divided by A dot B. So we may write it as A cross B mod in numerator as it is. We have A dot B equals to root 3 times of A cross B mod. So we can replace it by this term. Now this term and this term will get cancelled out. So you will get 1 over root 3. Now we have tan theta equals to 1 over root 3. So theta will be equals to 30 degree. Is it clear, Abhinav?
Yes, sir.
You all have written till this part. Rishan,
Yes.
next is projectile motion. So what do you mean by projectile? So you will say motion of a body in two-dimensional plane, that is along x-axis as well as y-axis, under the effect of gravity alone, then it is termed as projectile motion. So you say the motion of a body in two-dimensional plane under the effect of gravity alone is termed as projectile motion. Now, for this projectile motion, we have certain assumptions. First, air resistance is neglected. Next is horizontal velocity is constant throughout. Horizontal velocity to be constant. And next, value of gravity is also constant. Now, depending upon these assumptions, we may divide this projectile motion into different parts. One is called horizontal projectile, and the other is called angular projectile. Just write it down till this part, then we'll start horizontal projectile. Okay, Muhammad Umar, just write it down. I'm explaining you. You all have written?
Yes, sir.
Okay, Mohammed Umar, just see. What do you mean by projectile motion? It will be motion of a body in two-dimensional coordinate axis, that is along x-axis as well as y-axis, both simultaneously. Under the effect of gravity alone, then this motion is termed as projectile motion. Now we have certain assumption in this part. First is air resistance is neglected. If air resistance is neglected, then there will be no opposing force in any of coordinate axis, that will be x-axis or y-axis. So we assume horizontal velocity to be constant throughout and gravity to be constant. Is it clear?
Yes, sir.
Okay. So first is horizontal projectile. A body is projected from this point horizontally at some initial velocity u. So it will move along this path to hit ground at this point. This is y-axis, this is x-axis. So if we define its motion in two dimension, the body is initially at this point and going along this direction under the effect of gravity alone. It will be at this instant, this, and finally reach at this point. So this vertical motion in this body is due to gravity. And for a horizontal path, let's say from this point along this path to reach finally at this point, it will have due to horizontal projection or horizontal velocity. So you will say this body has motion in two dimension, that is along y-axis due to gravity and along x-axis due to horizontal projection. So on combining, you will say it will have two-dimensional motion, that is along both x-axis and y-axis. Now, using these two terms, if we define for any instant, let's say at this point, it will have one of velocity along x-axis as final velocity and along y-axis as Vy, and resultant of these two terms along this as V, which may be inclined at some angle theta with respect to horizontal. And if you define its coordinate, so it will be like this. The height from which the body has projected is termed as capital H, and total horizontal distance traveled by the body to hit the ground from point of projection is termed as range. Now we have to relate all these terms to find time of flight, height, range, velocity, direction, and so on. So in this part, a body, ball, stone, or anything is projected horizontally at uniform velocity u from height h above the ground, due to which we have two-dimensional motion. So we may break this motion into two parts. One is along x-axis and the other is along y-axis. So first write it down till this part. You all have written till this part?
Yes, sir.
Rishan? Okay. Motion along x-axis. In this part, we have initial velocity along x-axis as u. Since this is constant, so acceleration along x-axis would be 0, for which we may define final velocity using first equation, v is equals to u plus at. So it will be just u as acceleration is 0. So similarly, if you find displacement along x-axis, it will be s is equals to ut plus half at square, as a is 0. So it will be just u into t. Let this equation as 1 and this is equation 2. Similarly, motion along y-axis. Since body is projected horizontally, so there will be no initial component of velocity along y-axis, so it will be 0. Acceleration along y-axis will be g. So on the basis of these two terms, we can find final velocity along y-axis. V is equals to u plus at. U is 0, so you'll get just g into t. Equation third. And displacement along y-axis would be s is equals to ut plus half at square. U is 0, so you'll get half gt squared is equals to y. So this will be equation 4. Now, on the basis of these 4 equations, we have to define different terms related to this horizontal projectile motion. I'm defining you. First is time of flight. The total duration of time for which the body will be in air is termed as time of flight. So put the value of y to be h in equation 4. You will get t is equals to root under 2h divided by g. Similarly, if we rearrange it to find height, that is height of projection, so put the value of y to be h in equation 4. You will get h is equals to half gt squared. Now, if you want to find a range, that is horizontal distance traveled by the body, so put x is equals to r and t is equals to time of flight in equation 2. You will get r is equals to u into t, or r is equals to root of 2h divided by gravity. Is it clear till this part? Muhammad Umar, any doubt? Nida, is it clear?
Yes.
Okay. Similarly, we may find final velocity at any instant. To get this final velocity, just see in this graph, we have two terms. First is along x-axis, which is Vx, and second is Vy along y-axis. And these two terms are perpendicular to each other. So if you have to find V, that resultant of these two terms, so it will be V is equals to root under Vx squared plus Vy squared, in which Vx is equals to u and Vy is equals to g into t. So Vx will be equals to u and Vy will be equals to gt. Next is to define direction. Direction of motion of particle at any instant will be by tan theta equals to perpendicular over base, as we have perpendicular as Vy, base as Vx. Vy is equals to g into t and Vx is equals to u. So from this, you will get direction of motion of particle at any instant. Another term you may find that is called equation of trajectory. Trajectory means path traced by the particle during its whole projectile motion is termed as trajectory. So trajectory is nothing but path traced by particle during motion. So to define this path, we have to somehow or relate an equation only combining with x and y. So in second equation, we have x is equals to ut, and in fourth equation, we have y is equals to half gt squared. So if you relate those two terms, you will get a relation between x and y. So we can write from equations 2, t will be equals to x divided by u. Put this in equation 4. You will get y is equals to g divided by 2 times of u square times x squared. Now in this part, we have y directly proportional to x squared. So as we know, this is equation of parabola, or this will define you graph or curve parabolic. Hence we can say path or trajectory of projectile is parabolic in nature. Is it clear till this part? Abhinav?
Yes, sir.
Okay, just write it down. You all have written till this part?
So I'm still writing, right?
Done, sir.
Rishan, have you done? Okay. I'm giving you one problem related to this. A particle is projected so that it hits ground at 45 degrees in 3 seconds. So try to find first initial velocity of projection, second height of projection, third horizontal range, and fourth final velocity. Take g to be 10 meter per second squared. Just use the above formula and try to find these terms. We have given in this part theta is equals to 45 degrees and time of flight is equals to 3 seconds. Try to find. Just listen, there is one announcement. In next class, I will take your Viva, for which you have to prepare till product of vector. Okay? Is it clear to all of you?
Yes, sir.
In next class, I will take your Viva exam, for which you have to prepare till product of vector. Only vector till product of vector. Okay, just try to solve this. In above part, we have just derived 6 different equations. If you use tan theta equals to g into t divided by u, we have theta, g, time of flight. You will get initial velocity of projection from this equation. Similarly, to find height, just use half gt squared. To get range, use u into t. To get final velocity, first find Vx, then Vy, and put them in this expression. Try to solve, everyone. Good, Muhammad Umar. Good, Mohammed Umar. Good, Nida. Good, Nida. Abhinav, send me your answer.
Sending, sir.
Riba, just send me your answer. If we put all the values in this first part, as we have theta is equals to 45 degree, tan 45 equals to 1, g is 10, time is 3, divide by u. So you will get u is equals to 30 meter per second. Using second part, half g is 10 and t is 3 squared. So this term and this term will cancel out. So you'll get 45 meter as point of projection. Range is equals to u into t. U is 30, time is 3. So it will be 90 meter. U is 30 meter per second. G is 10 and T is 3. So it will be again 30 meter per second. So if you put these two terms in this expression, you will get 30 squared plus 30 squared whole root under. So it will be 30 root 2 meter per second. You all have got this result? Umar,
Yes.
Abhinav,
Sir, sir, how
which one? The last part.
v square?
Okay. 30 square is 900. 30 square is 900 root under. So it will be 1800 root under, or we may write 1800 as 2 into 900 root under. So we may break it as root 2 into root of 900. That's why I've written this term like this. Is it clear, Muhammad Umar?
Yes.
Okay. I'm giving you one problem related to this. A ball is thrown horizontally at you from top of stair whose each step is h unit height and w unit wide. Find the nth step on which it will hit again. In this part, we have suppose stair like this. And so on till this part. A ball is thrown horizontally from top of it. Let's say from this point horizontally at some initial velocity u. So it will move along this path to reach at this point, in which step of each stair is h unit height and width of each step is w unit wide. So if you draw a vertical line from this point and a horizontal line from this point, as each step is h unit height, so total height from point of projection to hitting the nth step will be h, and it should be n times of h. The total horizontal distance from the point of projection till it hitting the nth step would be range, and it would be equals to n times w from this point to this point. Now we have in this part height and range. So we have relation in between them. Just put all the values in that part and try to find n. As we have r is equals to u times root under 2h by g. Put the value of r and h and simplify it to get the value of n. Try to solve. Suppose if you put the value of R as n times W equals to U 2 times H, which is n times small h, divided by gravity. So just squaring both sides, it will be n square W square is equals to U square 2 times n into H divided by gravity. This n and this n will cancel out. So you're left with n is equals to 2 times U square H divided by gravity times width square. So this will be the nth step on which ball will hit again. Is it clear to everyone? Mohammad Umar, any doubt?
Yes, yes, sir, clear.
Good. You all have written?
Sir, I'm writing it.
Okay. Rishan, have you done? Okay. So next is angular projectile, or we may say oblique projectile. Suppose a body is projected from ground along this path to reach at highest point and then return back to hit the ground. So it will have y component and x component. Body is projected from this at some initial velocity u at inclination theta with respect to horizontal. So it will have two components. One would be along this direction. So it will be u times cos theta. And the other would be along this direction. And it should be u times sine theta. At highest point, there will be no velocity along y-axis. So it have only one component, that will be u cos theta. So at this point, body has attained maximum height, so it will be h. And at this instant, gravity will be perpendicular to velocity of projection. So you'll be asked to define a situation for which velocity is perpendicular to acceleration. So you'll say at highest point of projectile motion, or I will define you one more condition in circular path. Velocity will be perpendicular to acceleration.
Sir, can you define again?
At this highest point, since we have one velocity, which is along x-axis, that is u cos theta, and gravity is acting along vertically downward. So just see these two terms are perpendicular to each other. So you'll be asked to give a situation or give an example where acceleration is perpendicular to velocity. So it will be the highest point of angular projectile. Is it clear?
Yes.
Okay. As we defined in third chapter in motion with free fall, if horizontal level is same, then velocity of projection and velocity of hitting back to the ground will be same. So this body will hit ground with same velocity and at same inclination with respect to x-axis. So this will be theta, for which this will be u cos theta and this will be u sin theta. Is it clear till this part?
Yes, sir.
Okay.
Sir, where is u sine theta for the highest point?
As there is no component of y, so v sin theta will be 0. Okay.
Okay.
Now, if you define it, let's say body is starting from this point. So it will rise along this path to reach the highest point and then return back to hit back. Velocity of projection along this direction is u sin theta. So it will be some point at this, at highest point, since there is no further movement along y-axis. So Vy at highest point will be 0. Then again start descending back and will hit surface with same velocity as it was projected. If I define it for horizontal motion from this point along this path till this final, it will move along this direction due to u cos theta. At some point, it will be at this, and finally hit the ground at this point. So we can say this body has two different way of motion. One is along y-axis and the other is along x-axis. That's why it is termed as projectile motion. So we'll say a body is projected at velocity u at theta with horizontal. Now, on the basis of these components, we may define two different terms. First is initial velocity at point of projection. So it will have two different components. One is u cos theta I cap, and the other is u sin theta along positive y-axis. So it will be plus j cap. Similarly, on hitting back to the ground, it will have final velocity as u cos theta I cap minus of u sin theta j cap, as component of velocity along y-axis is towards negative y-axis. That's why here we have minus of u sin theta j cap. So if you relate initial velocity and final velocity, you will say there will be only change in sign of y component with respect to initial and final. Is it clear? Mohammed Umar, any doubt?
Sir,
Abhinav,
can you like briefly explain everything again? I couldn't understand.
if you relate from this point of projection, since we have two different component of velocity, one is along x-axis, that is u cos theta, which is along positive x-axis. That's why here we have u cos theta I cap, and u sin theta along positive y-axis. That's why we have u sin theta plus j cap. This is initial velocity or velocity of projection of body. On finally hitting the ground back, there is velocity along y-axis towards negative direction. That's why V final would be u cos theta positive I cap minus u sin theta j cap. So if you relate these two terms, you will say from point of projection till hitting back to the ground, there will be only change in direction of y component of velocity. Is it clear?
Okay.
Now, from these two terms, we may find first average velocity, which is equals to v initial, v final divided by 2. So if you put these two values in this expression, you will get u cos theta I cap. And next is change in velocity, which would be v final minus v initial. So if you put these two values, you will get minus of 2 u sin theta j cap. First, write it down till this part. You all have written till this part.
Yes, sir.
Muhammad Umar, Rishan? Now next is motion along x-axis and y-axis. We have initial velocity along x-axis as u times cos theta. Initial acceleration along x-axis is 0, as horizontal projection is always constant. So using these two terms, we may find final velocity along x-axis using first equation of motion as u cos theta. Let this term to be equation first. Next is to find displacement. S is equal to ut plus half at square. So it will be u times cos theta into t, as acceleration along x-axis is 0. Similarly, we may find for motion along y-axis, initial velocity along y-axis is u times sine theta, component of initial projection. Acceleration along y-axis from point of projection, take it as origin, so it will be minus g. So using these two terms, we may find final velocity at any instant would be u times sine theta minus g into t. Using equation first, let it be equation third. Next is to find displacement, so it will be u times sine theta into t minus half gt squared. So this will be equation fourth. And using third equation of motion, Vy squared is equals to u times sine theta squared minus of 2gy. Fifth equation. Is it clear to everyone? Nida? Any doubt?
No, sir.
Okay. Now, on the basis of these 5 equations, we have to find different terms related to this projection. First is time of flight. Total time taken by particle during its motion. So we put y is equals to 0 in equation 4. You will get u times sine theta into t minus half gt square equals to 0. If you take out t as common, you will left with u sine theta minus half gt equals to 0. Now, if you put individual term equals to 0, you will get t is equals to 0 first, and from this part, you will get 2 times of u sine theta divided by gravity. Since this time, which is 0, which will define you point of projection, and this time will define you total time taken by particle for this entire motion. So this will be termed as time of flight. Is it clear to everyone?
Yes, sir.
Next is maximum height attained by this body. So to get maximum height, as we know, at highest point, vertical component of velocity will be 0. So put Vy to be 0 and y is equals to h in equation 5th. You will get 0 is equals to u square sine square theta minus 2gh. On rearranging this expression, you will get h is equals to u square sine square theta divided by 2 times gravity. So this will be maximum height attained by the body. Similarly, we may find horizontal range. Total horizontal distance traveled by the body from point of projection till hitting the back to the ground. So put x is equals to r and t is equals to time of flight in equation 2. So you will get r is equals to u times cos theta into t, which is 2 times of u sine theta divided by gravity. So if you rearrange it, you will get u square 2 times sine theta into cos theta divided by gravity. This whole term is nothing but sine of 2 theta. So it will be u square sine 2 theta divided by gravity is equals to range. Muhammad Umar, any doubt?
No.
Okay, just write it down. You all have written?
Yes, sir.
Now I'm giving you a problem related to this. Body is projected at 3i plus 4j. Find first final velocity, second angle of projection, third initial velocity, and fourth range. I'm giving you a hint how to solve it. Just see in this part, we have V initial is equals to 3i plus 4j. As I have defined you above, there is a relation between initial velocity and final velocity, as just reverse the direction of y component in final velocity. So it will be 3i cap, and this 4j cap will become minus 4j cap, as there is only change in direction of y component of velocity from point of projection till it hitting back to the ground. Is it clear? Mohammad Umar, is it clear? Now, using these two terms, we may find coefficient of this I cap will be u times cos theta. So it is 3. And coefficient of j cap, that will be velocity along y-axis. So it will be u times sine theta equals to 4. So if you divide these two terms, you will get cot theta equals to 3 divided by 4. Now in this fraction, this 3 will behave as base and this 4 will behave as perpendicular, as cot theta is ratio of base and perpendicular. So using these two terms, we may draw a triangle for which theta is this. So base of this theta will be 3, perpendicular will be 4, and using Pythagoras theorem, you may find hypotenuse to be 5. Is it clear? Abhinav?
Yes, sir. Clear, sir.
Okay. Now, using this triangle, you may find the value of u by putting the value of cos theta or sine theta in these two terms. So u cos theta equals to 3. So if you put the value of cos theta using this equation, you will find u cos theta is base over hypotenuse. So it will be 3 by 5 is equals to 3. So u is equals to just 5 meters per second. Now using these relations, try to find value for range. Put r is equals to u square 2 times sine theta into cos theta divided by gravity. Take the value of gravity to be 10. Just write it down and try to solve for range. Put the value of u to be 5, sine theta to be 4 by 5, cos theta 3 by 5, and gravity as 10, and simplify it. For this range, u is 5, so it will be 5 into 5. 2 sine theta from this triangle, it will be 4 divided by 5, and cos theta will be 3 divided by 5, divided by 10. This 5 will cancel out with this part and this part. 2 into 4, 8 into 3, 24 divided by 10. So it will be 2.4 meters. You all have got the same result or a different one?
Same, sir.
Okay. Now, to solve this projectile in more simpler way, I'm defining you some of the relationship between these terms. Relationship between range, time of flight, height, theta, and so on. Whenever you have to relate any of the two quantity, just write them individually and divide. Suppose we have time is equals to 2 times of u sine theta divided by gravity. Range is equals to u square sine 2 theta divided by gravity. And height is equals to u square sine square theta divided by 2g. So in this range and height, we have u square, but in left part, that is for time, we have only u. So on dividing, we have to eliminate u square. That's why I'm taking t square equals to 4 times u square sine theta into sine theta divided by gravity square, so it will be g into g. Similarly, we may write this range as u square 2 times sine theta into cos theta divided by gravity, and this height is equals to u square sine theta into sine theta divided by 2 times gravity. Now, first for t and this range. So just divide them, t square divided by range. Put the value of t square first, so it will be 4 u square sine theta into sine theta divided by gravity into gravity. For range, it is u square 2 times sine theta into cos theta divided by gravity. So if we cancel out each term, which is common, so this g and this g will cancel out. u square will cancel out. Sine theta and sine theta will cancel out. So you're left with 2 and 4 will cancel out. So on rearranging, you will get g times t squared is equals to 2r tan theta. Muhammad Umar, is it clear?
Yes, sir.
Similarly, if you relate these two terms, you will get r divided by h. Put the value of r in numerator. So we have u square 2 times sine theta into cos theta divided by gravity. Next is height u square sine theta into sine theta divided by 2 times gravity. So if you simplify it, g and g will cancel out, u square cancel out, sine theta and sine theta will cancel out. So on rearranging, you will get r times tan theta is equals to 4 times h. So this is another relation between range and height. Now we may have to reduce these relationships to form together. We may write it as, if you combine them, we have in this part as 2r tan theta, but in this part as just r tan theta. So if you multiply this term by 2, you will get gt squared equals to 2r tan theta equals to 8h. So this will be your final relationship between time of flight, range, height, and theta. So if you know any one value, you will be able to calculate rest of the term without solving its formula. Abhinav, is it clear?
Yes, sir. Clear, sir.
Okay. Just write it down. All I've written?
Yes, sir.
Rishan, any doubt till this part? There is one more relationship in terms of equation of trajectory. If you have to find equation of trajectory, first, from equation 2, we may write t is equals to x divided by u cos theta and put this in equation 4. You will get y is equals to u times sine theta into t, and t is x divided by u cos theta minus half g t square. So it will be x square divided by u square cos square theta. So if you rearrange it, you will get u and u will cancel out. So it will be x tan theta minus g divided by 2 times u square cos square theta times x squared. So this will be equation of trajectory and this angular projectile. In this part, since y is directly proportional to highest power of x as x squared, so it is nothing but equation of parabola. So you will say path is parabolic in nature. Now we have to relate this equation of trajectory in some way to find relation with range. Just see how to relate it. We may write this equation of trajectory as y is equals to x times tan theta minus g divided by u square to sine theta into cos theta. I have just divided by sine theta. To compensate it, multiply it by sine theta and cos theta as it is times x squared. So this whole term is nothing but 1 over r. So you may write it as x times tan theta minus 1 over r times x square tan theta. Now, if you take out common as x tan theta from these two parts, you will left with 1 minus x over r is equals to y. So this will be a relationship between equation of trajectory with range. Abhinav, is it clear?
Yes, sir.
Nida, any doubt?
No, sir.
Muhammad Umar, any doubt till this part? You all have written?
Yes, sir.
Yes, sir.
Okay. Suppose if y is equals to x minus x divided by 10. So find first theta, angular projection, second range, third time of flight, fourth maximum height attained by the body using this. So I'm defining first how to relate it. Since we have y is equals to x minus x squared divided by 10. So we may first take out x as common. So it will be x 1 minus x over 10 is equals to y. So if we relate this expression with the above one, that is y is equals to x tan theta 1 over x by r. Just compare these two terms. You will say coefficient of x, that is this term and this term, must be equal. So on comparing, you will say tan theta equals to 1, theta will be equals to 45 degree. Is it clear how I just equated them? Similarly, you may define it as we have x divided by 10 in this bracket, and in this part we have x divided by r. So on comparing, you will say r is equals to 10 meter. Abhinav, is it clear?
Yes, sir.
Now we have both range as well as theta. So according to this relation, gt square is equals to 2 times r tan theta is equals to 8 times h. If you equate first these two terms, you will get time of flight. And if you equate these two terms, you will get height attained by the body. Try to solve using this relation. Take the value of g to be 10. If you relate first two term as g is 10, t square, we have to calculate 2 times r, which is 10, and tan theta 45 degree, so it is 1. So 10 and 10 will cancel out. So t will be just root 2 seconds. Similarly, if you relate last two term, 2 times r tan 45 1 is equals to 8 times h. So h will be equals to 20 divided by 8. So it will be 2.5 meters. Is it clear to everyone? Nida? Abhinav? Is it clear?
Yes, sir.
Okay, so let's stop here. Just revise this the whole part. I will define you some more relationship in this part. Then we'll start relative motion in 1 dimension as well as 2 dimension, the last part of this chapter. Okay. And one more important part, please prepare yourself for the Viva. Okay. Okay then, take care. Good night.
Thank you, sir.